In the beginning, there was nothing here but absolute silence and sands stretching endlessly. We're not talking about just a building, but a blatant challenge to the laws of nature, a bold human attempt to impose order on geological chaos in a spot untouched by civilization before. As this ambition looms on the horizon, we realize that the birth of a city doesn't start at the site, but in the minds of dreamers and on the screens of supercomputers. It's an ambitious vision that requires turning wild imagination into precise mathematical equations, where every drawn line weighs thousands of tons of real materials. Before laying a single stone, we must understand the enemy, the Earth itself. A comprehensive seismic and topographic survey is conducted, because the soil here is deceptive and may hide cavities capable of swallowing skyscrapers if not detected with extreme precision. Meanwhile, the first surveying teams emerge as reconnaissance forces in this engineering war. They use GPS with millimeter accuracy, because a single angular error here will mean a structural catastrophe 500 meters up in the sky later on. The harmony between beauty and engineering is an eternal battle. Architects want artistic fluidity, and structural engineers fight for stability and gravity. And every curve in the design means thousands of additional calculations for load distribution and wind resistance. For this reason, in virtual wind tunnels, the city is exposed to storms, simulating the worst climatic conditions of the next century. Buildings must breathe and move with the wind, not resist it with rigidity that leads to breaking. Then comes the moment of invasion, where a fleet of heavy equipment crawls toward the horizon, with engines of tens of thousands of horsepower, ready to tear up the Earth's surface and change the geography of the place forever. Here we're talking about moving millions of cubic meters of sand and rocks. This isn't just digging, but reshaping the Earth's crust to create the bed on which the city's enormous weight will rest. While every soil sample undergoes torture in laboratories, pressure, heat, and humidity engineers search for the breaking point, because knowing when the Earth fails is the key to ensuring it never fails under the city's burden. At the same time, logistics here equals managing an entire army. Steel from East Asia, glass from Europe, and concrete manufactured locally. Any delay in the supply chain could cost the project millions of dollars daily. Thus, the city that never sleeps begins as a site that never sleeps, where work continues around the clock, with successive shifts of thousands of workers operating like a synchronized beehive under blazing industrial floodlights. Since groundwater is the hidden enemy, before pouring the foundations, the site must be completely dried, using hundreds of massive pumps working day and night to lower the water table and prevent corrosion of future foundations. This very point, spanning just a few centimeters, is the center of gravity for an entire city. From here, coordinates will spread vertically and horizontally with non-negotiable precision. Then, the arrival of reinforcement steel marks the beginning of forming the bones, where tons of high-tensile steel are buried underground to act as nerves that bind the concrete and prevent it from cracking under enormous pressure. Now the stage is set, the Earth is bare, the plans complete, the machines ready. Planning time is over, and it's time to pour history into reinforced concrete molds. To achieve stability, we must dive into the depths, where giant pile drivers strike the Earth with force, penetrating soft layers to reach solid bedrock at a depth of 80 meters. Remarkably, not all piles rely solely on bearing at the bottom. Some work on the friction principle, where the soil grips the pile's sides with force that prevents the building from sinking in a physical dance of balance. Despite technology, the human eye is indispensable. Inspectors descend into the bowels of the Earth to verify the cleanliness of excavations, risking their lives to ensure the city's foundations are free of impurities. Then, giant steel cages are lowered, each weighing dozens of tons, with surgical precision into deep holes. These cages will be the buried backbone that supports skyscrapers. After that, special concrete is pumped from bottom to top to displace any water or mud. This chemical mixture is designed to resist corrosion and underground pressure for hundreds of years. After months of drilling, a field of concrete pile heads appears, where thousands stand like a silent army, ready to bear the weight of millions of tons that will be placed on their shoulders soon. The process of breaking pile heads is necessary to expose reinforcement steel and connect it to the next layer, a violent but necessary operation to integrate the lower system with the upper base. Meanwhile, a complex network of steel rebar is woven, so dense it's hard to walk through. This is the mat, the base that will distribute building loads evenly across all piles. Every wire node, every steel rod has a role in the equation. There's no room for chance here. The steel density is calculated to resist the enormous tensile forces that will try to tear apart the base when construction is complete. From here begins the largest concrete pour in history, where an unstoppable fleet of trucks arrives in an endless queue. The concrete must be poured in one go to avoid weak joints. As pump arms extend like giant arteries, pumping the project's gray blood, we realize timing is everything. If the concrete dries prematurely, the entire base will fail. However, the concrete's chemical reaction generates enormous heat. If the temperature rises too much, the base will crack from within. So we use water coolers and ice inside the mix to control this exothermic reaction. Since air bubbles are the enemy of solidity, teams of workers dive into the wet concrete with vibration equipment to expel air and ensure maximum material density around the steel. Over weeks, the base hardens and transforms into a single artificial rock of enormous weight and depth. This is the anchor that will prevent the city from drifting or sinking. In seismically active areas, buildings aren't fixed directly, but placed on massive rubber and steel pads. These isolators absorb shocks and allow the city to dance with earthquakes instead of breaking. Since moisture is a silent killer for steel, foundations are wrapped in layers of fire-melted rubber insulation, a waterproof shield to protect the structure for 100 years to come. The underground city is no less complex than the one above, where multiple floors of parking and service tunnels begin to appear, like a hidden arterial network that will serve thousands without them seeing it. Even underground, the city must breathe, so giant air passages are installed to ensure fresh airflow and exhaust fumes are drawn from the dark depths. Before we rise, we need cranes. Tower crane bases are fixed in the foundations themselves to grow with the building and become a temporary part of its structure. Finally, columns pierce the Earth's surface. This is the moment when the project transforms from a hole in the ground into a structure reaching for the sky. The ascent has begun. Then, wood and aluminum forms are installed with laser precision. These forms will determine the shape of columns and walls that will carry the first floors, and any lean here will multiply as we rise. From the air, trucks look like small toys compared to the size of completed foundations. This scene embodies the grandeur of human engineering and its ability to shape materials. The numbers don't lie. Concrete compression test results must match expectations exactly. If the concrete is even slightly weaker, the section is demolished and rebuilt. There's no room for risk. Meanwhile, the electrical grounding network is buried now. It's the safety valve that will protect the city and its residents from lightning and electrical faults by discharging excess charges into the Earth's interior. After completing the lower floors, soil is backfilled around walls and carefully compacted. This lateral support helps stabilize the building and closes the Earth's open wound. Then slipform technology arrives at the site. This smart hydraulic system will allow the building to grow continuously without stopping, where the form itself climbs upward with each concrete pour. Since safety is paramount here, thousands of workers in their orange clothes receive strict instructions. In an environment full of heavy steel and deadly heights, discipline is what keeps you alive. The concrete we'll use in the central core isn't ordinary. It's a superfluid, high-strength mix designed to flow between dense rebar without leaving air pockets. Thus, the building's core, or concrete heart, begins to rise. This is the backbone that will contain elevators and stairs, and it's the essential element that gives the skyscraper its rigidity against winds. With the foundation phase ending, we bid farewell to the Earth and welcome the sky. The hardest and most expensive part is done, the part no one will see again, but it's the most important of all. From here, the symphony of steel in the sky begins, where tower cranes work as giant mechanical arms, lifting beams weighing dozens of tons and placing them in position with surgical precision that defies gravity. These men, the steel tamers, walk on the edges of the abyss. Their job is to connect the structure together with giant bolts, relying on safety harnesses and rare courage to build the city's skeleton. Every bolt here is an engineering masterpiece, tightened with precisely specified torque. The applied force must be enough to weld metal to metal, but not enough to break the bolt under pressure. Simultaneously, the self-climbing formwork system is a mobile factory that rises with hydraulic power, carrying workers, concrete, and equipment, rising floor after floor without needing external cranes, dramatically speeding up construction. Pumping concrete to towering heights requires special physics. Pumps generate enormous pressure to overcome gravity, and pumping pipes must withstand friction sufficient to tear ordinary steel. With height, the building tends to sway, so sensors linked to satellites monitor the tower's straightness moment by moment, ensuring it rises perfectly vertically despite wind movement and sun that expands one side more than another. Floor slabs aren't just concrete, but start as corrugated metal sheets. This composite surface provides an immediate work platform for workers and increases bonding strength with the concrete poured over it. Meanwhile, welding sparks scatter like stars in the city night. Welders fuse steel elements to become one piece, in a process requiring thermal precision to ensure the metal doesn't weaken at connection points. At certain points, massive outrigger braces are installed. These steel arms connect the central core to outer columns, giving the building stability resembling a skater's stance to resist bending forces. Of course, crane operators are masters of the horizon, living in isolated cabins for hours, controlling tons of materials with millimeter precision, relying on wireless directions from the ground they can barely see. But how do you build a crane taller than itself? Climbing cranes push themselves upward using hydraulic pistons, adding new sections to their spine to rise with the building step by step. Since wind at high altitudes isn't a steady stream, but chaotic eddies, the building's shape is designed to scatter these eddies, basically confusing the wind to reduce tower sway and keep residents from feeling seasick. To cut down on columns and maximize space, we use post-tensioning. Steel cables inside the slabs are pulled with massive force after the concrete hardens, compressing the slab and giving it exceptional load-bearing strength. Temporary elevators are the vertical lifeline. They transport thousands of workers and equipment daily, and even one elevator breakdown means the entire worksite grinds to a halt, so maintenance is critical. Amid the steel and noise, there are human moments. Workers eat their meals with views that even billionaires don't have. Unknown builders, creating tomorrow's glory with their rough hands. Since steel loses strength at high temperatures, every inch of it gets sprayed with fireproof coating. This gray shell is what will buy the building time to hold up in case of a catastrophic fire. Time management here is both art and science. While the 50th floor is being poured, glass is being installed on the 30th, and interior finishes are happening on the 10th. Overlapping tasks is essential to complete the city on schedule. Meanwhile, the mechanical risers appear like the building's intestines. High-pressure water pipes, electrical cables as thick as arms, and massive air ducts climbing the central core to feed life to every floor. To speed things up, huge sections are assembled on the ground using robots. This ensures better welding quality and reduces the risks of working at extreme heights. Of course, nature doesn't stop for us. Storms and rain turn the site into a slippery, dangerous arena, so temporary drainage systems must work efficiently to prevent the building from becoming a giant waterfall. The higher we go, the more precision matters. Laser devices measure deviations down to the micron, because any slight tilt now will become meters at the top, something that's unacceptable engineering-wise. Then a steel truss belt wraps around the building at mid-height, acting like a compression belt that ties the outer columns to the core, distributing loads and reinforcing the structure's rigidity against twisting. As we climb, the concrete walls get thinner because the loads decrease, so we lighten the weight to save materials and increase usable space in this precisely calculated engineering sculpture. Meanwhile, waste management in the sky emerges as another challenge. Trash chutes carry construction debris from hundreds of meters up to ground-level containers, keeping work floors clean and safe. Since connection points between columns and beams are high-stress concentration zones, the design ensures these points are flexible enough to absorb energy and strong enough to prevent collapse. Because a hammer dropped from this height becomes a deadly bullet, safety nets surrounding the building are the last line of defense, protecting workers below and passers-by from falling objects. Mechanical floors are the building's power plants. Cooling towers and massive generators are lifted and secured on dedicated floors to function as the heart and lungs of the internal ecosystem. With every sunrise, the skyline's shape changes. The skeleton gains its features, transforming from mere lines on paper into a reality that dominates the landscape. Since elevator ropes aren't ordinary, they're made from carbon fiber or specially braided steel to handle the weight of cars and passengers over enormous vertical distances without stretching. In emergencies, stairwells are the escape route, so huge fans are installed to pressurize the stairwell air, preventing smoke from entering during a fire and creating a safe escape path. Since architectural concrete isn't covered, it must be flawless. Specialists inspect the surface smoothness and color uniformity, Any casting mistake will be visible forever. We're not building just one tower, but an entire neighborhood. A symphony of cranes at multiple sites, where each tower rises in harmony with its neighbors to shape a unified visual identity for the new city. Truck movements are coordinated through a central control room. Thousands of daily trips are scheduled to the minute to prevent bottlenecks that could halt work across all sites. To boost efficiency, we use double-deck elevators. This requires double precision in track installation to ensure smooth, safe movement of two cabins traveling together at high speed. Since every building has a natural vibration frequency, engineers tune dampers to counteract this frequency, preventing the building from resonating with wind or earthquakes, a phenomenon that could lead to collapse. Suspended bridges between towers present a unique engineering challenge. Structures weighing hundreds of tons are lifted and fixed between two independently moving buildings, requiring extremely complex expansion joints. Because silence is the ultimate luxury, advanced sound insulation is sprayed between floors and walls to isolate city noise and mechanical systems, creating an oasis of quiet in the sky. Before installing the glass, the secondary structure must be prepared. A precise network of lightweight steel is welded carefully to form the framework that will support the building's glass skin. The helipad at the top requires special engineering. It must withstand the impact of a helicopter landing and be equipped with automatic fire suppression systems and safe fuel lines. Meanwhile, the water tanks at the top aren't just for drinking, but work as liquid dampers. The water movement inside them counteracts the building's swaying motion, providing smart dynamic stability. When we reach the top, the self-eating process begins. Small cranes are lifted to dismantle the large cranes and lower them piece by piece, in a dangerous and complex operation at extreme heights. Then comes the topping out ceremony. The last steel beam, signed by everyone who contributed to the construction, is raised, decorated with a tree and flag, in a moment of pride and celebration, marking the completion of the skeleton. Now the giant stands structurally complete, 1,000,000 tons of concrete and steel piercing the clouds, testimony to boundless human ambition. Yes, the building moves. In strong storms, the top may shift several meters, and this flexibility is the secret to survival. A building that doesn't bend to the wind breaks. At the highest point, aircraft warning lights are installed. These red beacons are the first thing pilots see, operating continuously to ensure airspace safety. From here, the ground seems distant like another world. We're literally above the clouds, in a sky kingdom that engineers have conquered with boldness and determination. After the climbing formwork system has done its job, it's now dismantled. Removing these massive structures reveals the final shape of the concrete core for the first time. As work progresses upward, scaffolding is removed from below. The building begins to reveal its leg, showing its true features to the public at street level. Inside, the division of empty spaces begins. Chalk lines on the floor mark locations for walls and rooms, transforming open spaces into future apartments and offices. Then, an army of workers installs metal studs for interior walls. With amazing completion speed, floors transform from skeletons to defined rooms within days. The fire suppression network remains a top priority. Thousands of sprinklers and miles of pipes covering every square meter, ready to operate upon detecting heat to protect lives and property. While power arteries are threaded inside walls before closing them with thousands of kilometers of copper wires, we realize they'll carry electricity and data as the lifeblood of the smart city. Before covering, the water network is pressurized to the maximum to detect leaks. A single water drop now could cause a costly disaster later, so testing is strict and uncompromising. Then rock wool and thermal insulation are stuffed into the walls. This isn't just for comfort, but for energy efficiency, so the building maintains its coolness in summer and warmth in winter at minimal cost. After that, gypsum boards seal the walls and hide the complexities of systems behind them. What we see is a smooth white surface, but behind it is a complete world of mechanical and electrical engineering. A final leveling layer is poured for the floors. They must be perfectly level to receive marble or wood, and laser is used to ensure their levelness with extreme precision. Meanwhile, escalators arrive as one piece and are inserted through openings made specifically for them, in an operation requiring precise maneuvering to avoid damaging the surrounding structure. In the main lobby, art meets engineering. Marble slabs are selected and installed so their veins match like a mirror, creating natural artistic paintings covering walls and floors. The giant chandeliers aren't just lighting, but engineering structures in themselves, requiring special reinforcement in the ceiling to bear their weights, which may reach tons. The smart city's brain lies here, in cooled server rooms containing the digital infrastructure that will manage everything from lighting to security, connected by ultra-high-speed fiber optic networks. Thousands of sensors are planted in ceilings to monitor movement, temperature, air quality, and even daylight to adjust the building's environment automatically and save energy with artificial intelligence. Since industrial kitchens on upper floors require gas and special ventilation, designing smoke and odor extraction systems from this height is a mechanical challenge to ensure air purity. Meanwhile, a swimming pool suspended in the sky stands out. Since water weight is enormous and its waterproofing must be perfect, any leak here means disaster for lower floors, so it's tested for weeks before opening. We bring nature to the sky, with real trees and special lightweight soil lifted to create hanging gardens, as a green lung amid concrete and steel. But how do we clean skyscraper windows? Complex facade maintenance cranes are installed at the top as mechanical arms that will allow cleaning teams to reach every square meter of exterior glass. The building's skin isn't ordinary glass. It's a multi-layer system, coated with fine metals to reflect the burning sun's heat while allowing light to pass through, as a highly sophisticated, transparent thermal insulator. Handling glass panels, weighing hundreds of kilograms in the wind, requires powerful suction robots. Each panel is fixed with millimeter precision to become part of the outer shield. The building must be sealed tight as a submarine. Pressure tests ensure no air-conditioned air leaks outside, raising energy efficiency and protecting the building from dust and humidity. The air conditioning system is the lungs. Giant units process millions of cubic meters of air, cooling it, purifying it, and pumping it through kilometers of ducts to ensure a cool breeze in the heart of the desert. While the central cooling plant consumes energy sufficient for a small city, the giant chillers work non-stop to remove heat generated by the sun, people, and devices inside this giant. Nothing is wasted here. Energy recovery wheels capture coolness from exhausted air before expelling it and use it to cool incoming fresh air, in a technology that saves millions of watts annually. Elevator motors are electrical beasts, capable of lifting a cabin full of people at 10 meters per second, with a smart braking system that generates electricity when descending. Since fast-moving elevators push air ahead like a piston, special ventilation openings and aerodynamic cabin design are necessary to prevent air pressure from disturbing elevator passengers. The city also generates its own power, with solar panels integrated into the facade and roofs converting bright sunlight into clean electricity, contributing to reducing the project's carbon footprint. Since water is a rare commodity, we recycle it. Water from sinks and showers is treated in special plants in the basement to be used for watering gardens and cooling systems. In a closed water life cycle, the facade is smart and interactive, with automated curtains that move with the sun's path, opening to allow light and closing to reduce heat. In a daily dance, managed by precise computer algorithms. No garbage trucks here. A pneumatic suction system pulls trash from every floor through vacuum tubes at high speed to a distant central collection station. With extreme cleanliness and futuristic technology, in the command room, every watt is accounted for. Monitors analyze energy consumption data in real time, balancing loads and optimizing efficiency to ensure economical and sustainable operation of this edifice. Since water destroys electronics, we use gas. In server rooms, special suppression systems release inert gases that suffocate fire in seconds without damaging sensitive equipment. When power cuts out, darkness must not prevail, so massive backup batteries and diesel generators are ready to operate within fractions of a second to illuminate emergency paths and run vital elevators. Security here is digital, with iris scanners and fingerprints controlling access. The system knows who you are and where you're allowed to go, providing impenetrable security. Celebration halls are tuned like musical instruments. Sound engineers use precise devices to adjust sound reflections, ensuring a perfect auditory experience free from annoying echo. The facade transforms into a giant screen, with millions of LED points integrated into the glass, allowing the building to communicate and display visual arts, turning night into a digital canvas. Under the streets, the district cooling network connects buildings to each other. Chilled water flows from central stations to air-condition entire neighborhoods as a smart collective solution that reduces individual energy consumption. Lightning rods at the top are the guards. A network of thick copper captures the sky's massive charges and passes them safely to the ground, as necessary protection for a skyscraper flirting with clouds. Indoor air quality is purer than outside, thanks to advanced filters that remove dust, pollutants, and bacteria, providing a healthy and sterile environment for residents away from city pollution. Even parking is smart. Sensors above each spot guide drivers to vacant spaces, a simple system that saves fuel and time and eliminates the hassle of searching for parking. The building's voice must reach everyone, so the public address system covers every corner, designed to deliver emergency messages with complete clarity, even amid alarm noise. Final touches highlight luxury, from polishing stainless steel and glass until any trace of construction disappears, so the building shines with the gleam of cleanliness and newness. Removing protective coverings is an unveiling moment. Virgin surfaces appear for the first time, scratch-free, ready to reflect the city's new face. The final test is the worst-case scenario. Main electricity is intentionally cut to ensure emergency systems will work immediately, in a breath-holding moment to verify the beast's readiness. After millions of work hours, the moment of truth comes. Inspectors sign occupancy certificates, and now, only now, the site transforms from construction zone to living city. Red carpets are rolled out and lights are prepared, while the world awaits the unveiling of the miracle, crowning years of sweat and effort in one night of legendary celebration. Life flows into concrete veins, with the first residents entering, their eyes amazed by the luxury and size. And what was a dream and drawings has now become their home and tangible reality. At sunset, magic happens. Thousands of windows light up, and the city's arteries pulse with electricity. As darkness is defeated before the glow of human achievement, the city's crown gleams in the sky. As a beacon visible from 100 kilometers away, it's a symbol of defiance and a loud declaration that we're here and that we're capable of touching the stars. The building isn't stone, but people, with laughter in gardens, deals in offices, and quietness in homes. This is the true spirit inhabiting the engineering structure. We now remember the challenges, the scorching heat, fierce winds, and enormous pressures. Every obstacle was overcome with science and will, and every problem turned into an innovative engineering solution. Behind this beauty, an army of unknown heroes, the thousands who poured their sweat with the concrete. This edifice is a memorial to their collective effort and silent dedication. We've changed the place forever. The city is so massive it creates its own climate, affecting wind movement and clouds. We've rewritten the region's geography. This construction is designed to last, not for decades, but for centuries. Concrete gets harder with time, and steel is protected to outlive its makers. It's a legacy for the future. From space, the city appears as a bright point of light on Earth's dark face, a civilizational footprint confirming that humans, despite their smallness, are capable of making wonders. Coming generations will stand here and raise their heads in amazement. They'll ask, how did they build this? And the answer is, with science, boldness, and faith that the impossible is just a point of view. From a grain of sand in a barren desert to a skyscraper embracing clouds, an epic journey from nothing to the top, a story of struggle and the triumph of the human mind over matter. This is how cities are built. This is how we make the future. And this is how humans immortalize their names in the history record, with letters of light and stone.